So what do you mean by OTV? OTV is the Overlay Transport Virtualization. Okay. So basically what happens, the basic idea behind OTV was that it extends layer 2. It extends layer 2 boundary. So what do you mean by extending layer 2 boundary? So suppose in the traditional network, what happens? Suppose this is your, MPLS cloud and this is your DC1, right? And suppose this is your DC2 or this is your site 1, right? So each data center or each site must have your separate IP addressing schema, right? So suppose if you are using 10.10.10.0/24, so here you will be using 10.10.11.0/24. So IP schema should not be clashed, right? Otherwise your returning traffic will be always disturbed and you will get the, sometime you will get the packet, sometime you will not get the packet. Suppose
like
you
VRF,
started a ping.
like VRF, it will be confused until you put the RB in R packet, right? Two distribution.
Yes.
Same thing. Yeah.
So if you are using a same subnet, then obviously you can go for the VRF. But ideally, in general case, what happens? Your subnet should be separate and it should be unique in nature. I mean the subnet should be they should not overlap to each other in each of the sites and each of the data center.
Right.
Now sometimes it happens that that you want that this subnet 10.10.10.10.0/24 you need to also use that subnet in some of your other sites also, right? So it may be possible, right? So suppose you want to extend your subnet from one data center to another data center. So how you will do that? So there may be a couple of scenarios. First one is that you have a data center switch. You connect a long fiber cable, we can say as a black fiber, and connect to your site 2, right? You made it at a trunk port, and here it is SVI, and here you can connect in the site 2 also you can have a same VLAN, put the PC in your same VLAN and they can reach. But this black fiber is very costly, because suppose if your data center is in Toronto and your one of the site is in Houston or New York, you can't afford to have such a long black fiber because it will cost a lot, right? Second, we have a solution that we can use VPLS, right? It's just a layer 2 VPN. So in that case, you have to take the VPLS.
Sir, can we use MPLS layer 3 VPN?
In that case, you can use the MPLS layer 3 VPN, right? But again, MPLS layer 3 VPN will only be used if you're all from you are from site 1 to site 2 or site 3. If you have end-to-end VRF, but generally it doesn't happen, right? Because once your traffic reaches to the cloud, MPLS cloud, then the MPLS label switching happens. It doesn't happens, right? And the VRF is generally used for the service provider point of view. Not you will not use lots of VRFs in your data center because it will be very unhealthy to manage it. Second thing, you can use VPLS. It is just a layer 2 VPN, but again you have to take a layer 2 circuit from the service provider and they will charge according to it, right? So these are some drawbacks of extending your existing network from one data center to another, or you can say you cannot extend your layer 2 boundary from one data center to another data center or a site, right? Or if you want to extend your layer 2 boundary, then there are these 2 or 3 features are available. You can do that, but these are financially very costly. They are cost expensive. They are time consuming. Troubleshooting is very tough. All the other things are related to that.
So we cannot have a black fiber from one side.
The black fiber is an option, but if your sites are very nearby, right? If your sites are if your 2 sites are one corner of the country, then it's very difficult. You can't take a black fiber just because it's very costly, very costly. And sometimes also due to the reasons, I mean due to the physical reasons, service provider also doesn't provide the black fiber end to end. There may be some mountains, rivers. How can they go everywhere, right? So sometimes due to some feasibility conditions also you cannot have the black fiber always. So to avoid these two situations, the Cisco developed the OTV. So it's a overlay transport virtualization. What it says that okay, boss, whether you have any type of network, MPLS, IP, point to point, any.
Hello, I just want to ask you if you don't mind. Sir. So, like in the production environment, like ISPs, like India and in India and everything, are they using MPLS layer 2 VPN or layer 3 VPN?
Here both are used, layer 2 also, layer 3 also, but mostly we are using layer 3 VPN.
Okay, but the production environment mostly will be using layer 3 VPN with the VR.
Yeah. Okay. Right.
Okay.
So OTV what says that whether you are having MPLS, IP network connectivity, or point to point circuit, till the time you have a IP reachability of the two sites, right? So suppose this site having 192, 168, 1.2, this site is having 172, 16, 1.10. What I mean to say that these two sites, if they have a IP reachability to each other, right, in any format, either you have a MPLS circuit or a point-to-point circuit or any type of circuit, so you can extend your layer 2 boundary. The 10.10.10.0/24 subnet, you can extend it from a DC1 to DC2. So you can use this subnet here also via OTV. So OTV runs over your existing IP network infrastructure. Okay, understood?
Yeah.
Now
on the MPLS.
On the MPLS or anything. So what does it benefits? What it says, the benefits are, it extends layer 2 LAN over any network that support IP. I mean to say, till the time you have a IP reachability of the two sites, anyhow, you can extend your layer 2 LAN. How you can extend? Via OTV technology, right? It is designed to scale across multiple data centers. So you can extend these, OTV in the multiple data center, right? It is very simple. When there are simple minimal commands are required, you can easily configure it and you can see that, right? Resiliency, preserve the existing layer 3 failure boundaries. If you have a primary or secondary link in your existing data center, you can use that. So OTV, it also oscillate from primary to secondary. If your primary goes down, your traffic can OTV traffic can go via secondary.
So OTV is used on an existing MPLS network, huh?
Correct. And not MPLS, it can be any IP traffic. It is MPLS, IP network, internet, if you have a point-to-point circuit. So suppose this is site 1 and this is site 2, and you have directly connected via point-to-point circuit, and these are able to ping to each other. You can extend your layer 2 boundary
by using OTV.
Any network that support IP, you can extend your layer 2 boundary via OTV. Right? So, and it is efficient enough, it optimizes the bandwidth.
You can have the same subnet on the two sides.
Yes, correct. And you can also use equal cost multipathing, right? You can use, if you have a 2 or more, concurrent redundant link, and each are having an equal cost multipath, right, to all the sites, you can optimize your bandwidth. So these are some OTV bandwidth, right? Additional bandwidth, if you want to ask some additional, benefits, then there's no need of UMPLS or VPLS, right? No need of, no need to procure or, order a specific layer 2 circuit from the service provider. You have already MPLS link, you can extend your layer 2 boundary. If you have already activity via point-to-point network, you can obtain, there is no need to specifically order and pay for your, to, extend your layer 2 boundary. use any network that support IP. Okay, provision of layer 2 and layer 3 connectivity using dark fiber connections. You can use also that. Native STP isolation. The STP doesn't work between. Why? Because you are extending your layer 2 boundary, right? So it doesn't mean that your BPDU will also travel. No, BPDU, your STP of 10.10.10.0/24 will be local here, and the STP of 10.10.10.0/24 is local to here. There will be no BPDU going across.
Okay.
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 ARP resolution.
Both the sites you're using now on PLS, are they using dark fiber?
You can use dark fiber, no problem.
Okay.
Right.
But in the production environment, what they use, like in OTV, dark fiber or?
No, MPLS. MPLS is the best solution.
Okay. On the MPLS, you're putting OTV, that's all.
Yes. Okay. And you can add as many as number of sites. Okay, and you can make a MPLS OTV.
Now, I want to ask you, when you are having a MPLS connectivity between two sites, what kind of fiber do you use? Do you use dark fiber or use like?
No. They use see what happens. They generally use the fiber cable.
Fiber optics, right?
Yeah, and here they configure the MPLS configuration. So all the traffic coming exiting via this interface, they on the Ethernet, MPLS label is connected, attached.
Because of labels,
and then they go to the MPLS cloud, and then they go to site, and then they go to blah blah.
It's all connected. All the IC connected.
Yeah. Yes.
Interconnected.
Yeah. Right. So what are the components? Right. So component is, see here, this is any transport. It should be IP transport, simple. Whether it is MPLS, dark fiber, IP to IP connectivity, or a point to point. Right? So OTV delivers layer 2 extension or any type of transport infrastructure. Till the time you must have the two IP addresses of the two different sites, you should be able to ping to each other, right? The device over which you configure the OTV, we say as a OTV edge device. Okay? So the device over which we configure the OTV configuration, we say as a OTV edge device.
So OTV is nothing. It's just an extension of the layer 2 network
over a layer 3.
Across any IP transport. That's all simple.
Yes.
Right. Extension of a layer 2 where you can have the same subnets on both the sides across IP transport. Transport could be MPLS, point to point, anything.
Anything, right? Correct. And the device over which you are configuring the OTV, we say as a OTV edge device. Okay. Now, the interface through which the OTV packets exit, right? The exit interface over which your OTV packet goes out to the IP network, we say as a joint interface. What we say as a joint interface. So the traffic from traditional, switch, it comes here, Ethernet packet, that OTV packet header is applied, and from there it goes from this device, and then it goes to the IP network. So the interface through which your OTV packet exit to the network, we say that interface as a joint interface. And that interface should be layer 3 interface. I mean, it must have IP configured on this interface. Okay. See, as we say that we configure a layer 2 VLAN and a layer 3 VLAN, right? So layer 2 VLAN is a VLAN ID and a VLAN name. Layer 3 VLAN is an interface SVI. I mean interface VLAN 10, and we provide an IP address. The same way we configure a logical overlay interface. So what is OTV overlay interface? OTV overlay interface is a logical interface which encapsulates or decapsulates the Ethernet traffic, right? It encapsulates Ethernet traffic to OTV packet and decapsulate the OTV packet to traditional Ethernet packet, right? So suppose if I have a switch connected here, normal plain switch, and this switch is sending a common normal Ethernet packet, right? Now when my traffic reaches to logical overlay interface, what happens? The overlay interface put a OTV packet and it forwards to the interface we say as a join interface. So through join interface, my OTV packet exits, and the OTV overlay interface is a logical interface. It is just like a logical VLAN we configure, right?
Okay.
Your infrastructure should be multicast or unicast transport supported. Okay, your transport infrastructure should be multicast supported.
Multicasting.
Yeah. You can both, it unicast, anyway it supports the unicast, but it should be multicast supported also. Okay. Now those interface through which our local LAN is connected to the our edge device we say as an internal interface. So internal interface are those interface on the OTV edge device through which we can connect our existing layer 2 switches or a layer 3 switches, I mean Ethernet switches, over which there should be no OTV configuration, right? Okay. Now, so what happens once your, suppose this is your switch, here you connected a LAN environment and it is your server. So suppose this server sends a traffic to the switch sends the traffic to your OTV device. So generally the Ethernet packet is of 1500 bytes.
Yeah. Each interface is 1500 bytes.
Yeah. Now, once the traffic reaches to your overlay interface, what happens on your Ethernet packet? Your OTV header applies. So this header is of 42 bytes. So your size of your traffic is 1542 bytes. So make sure all your layer 3 interfaces throughout your data center and in your even your MPLS cloud also, it should support jumbo frame. Jumbo frame means, I mean, it should support 9200 byte packet. So on each layer 3 interface, I will configure a 9200 MTU size.
By default,
here
it's
also
1500 bytes, right?
By default, it's 1500 bytes.
So if they configure it for 9200 bytes.
Yes.
Okay.
Why? Because once you configure OTV on the Nexus device, the Nexus doesn't fragment or segment the traffic. Generally, what happens if a packet comes greater than 1500? So what happens? The switch or a router, it fragments it. It fragment it to smaller packet, right? Yeah. So less than 1500. But in the case of OTV, if you have configured OTV on the Nexus device, and if any packet coming more than 1500, it will not fragment it. So in that case, you have to increase the MTU size on each of the layer 3 interface from data center 1 to data center 2. Otherwise, if you will not increase the MTU, the packet will be discarded. It is the only specific case of in the OTV only. Otherwise, if you don't configure the OTV, the Nexus device will fragment the packet if it receives the packet greater than 1500. But if you configure OTV on the Nexus device, it forgets the fragmentation. So to support,
it will not fragment.
Yeah, it will not fragment if you configure the OTV only, right? Or if in that case only it will not fragment. Right. Otherwise, it will fragment everything.
What happens is if we have 5000 bytes on one interface, it will do fragmentation, right?
Yes. The same case happens in the Nexus also, right? But if you configure the OTV then the Nexus device will not fragment. So in that case, you have to configure a MTU size on each of the layer 3 interface, so that if any packet greater than 1500 reaches to your device, it should not discard it, rather it should allow it to your IP network. Right?
Yeah, in normal scenarios, if you have 5,000 bytes, it will fragment. Normal scenarios.
Yeah. So I said what is edge device, internal interface, join interface, overlay interface, site. Yeah. What is site VLAN? Site VLAN is a VLAN. Suppose if you have each site, suppose you have a 2 OTV edge device. You use it for redundancy. So communicate between these two, site VLAN is used. Right? Site identifier is a unique identifier which you will configure for each site. So each site must have a unique identifier. If you don't configure a unique identifier on each site, your OTV will not come up. Okay, so each site must have a common unique site ID. It should be unique. MTU is greater than 1542, right? You have to configure it. It separates SVI separation. It provides FHSRP isolation. I mean, so suppose what does it mean? So suppose there is a cloud and you have OTV configured and you are using the same 10.10.10.0, 10.10.10.0, and here also you configured HSRP and here also you configure HSRP. So each SRP must have a virtual MAC address. Here also it will have a virtual MAC address. So that MAC address will not be going from one where to another. It will be local to the sites. Only the data traffic travels. Okay. So it should be multicast supported, right? It supports also unicast layer support. OTV extend VLAN is those VLANs which you are going to extend from one data center to another data center. You can also use the OTV authentication. I mean, if you want that your OTV packet should be authenticated, you can configure authentication, right?